following is your bell rates for section 5.4 and 5.5. Complete it and send it in with your homework. Okay, so section 5.6. Okay? Section 5.6 is all about confidence intervals. So it's all about confidence intervals. And when we discuss confidence intervals, basically, it's a way of displaying data. We see confidence intervals and different things of displaying data out on commercials all of the time, right? 3 out of 5 dentists prefer us to use, what, Colgate or Crest, or is it 4 out of 5, okay? But they display their data in some sort of statistical method. Did they only ask 5 dentists? Probably not. They probably asked over 100 or 200 dentists, and 160 out of 200 prefer one thing, right? Okay. Well, or potentially, I hope that they don't make it up, but potentially they could make it up. But we're hoping the asked dentists got their opinions, right? And those dentists weren't paid off, right? We're being really, really thinking the world is rosy and wonderful, right? So it could be 160 out of 200 dentists prefer Colgate, right? Or Crest, or whatever it is. But, you guys, 160 out of 200 sounds funny. So what do? They simplify their data. They say 4 out of 5, or 3 out of 5, depending on what it actually rounds down to, right? They don't say 80%, they say 4 out of 5, because 4 out of 5 sounds better than 80%. But it's the exact same thing. You know why they do that? Because 4 out of 3 people are really horrible at fractions. Come on, that's a good joke. 4 out of 3 people are really good at fractions. No, horrible at fractions. That's a good joke, you guys. Right? So why do they do that? Why? Because fractions are your nightmare, right? And people just go, oh, that must be good. They're talking in fractions for us. Okay? Some people love fractions. Okay? It's okay to love fractions. Fractions are our friends. Okay? So when we talk about confidence intervals, there's a few terms we need to know about, and I'm just going to note you to the side here, because it's all about knowing what this stuff means. Okay? So the margin of error. The margin of error right here, it's the possible difference between the estimate of the value you're trying to determine as determined from a random sample and the true value for the population. The margin of error is generally expressed as a plus or minus percent, such as plus or minus 5%. Okay? So a margin of error is just kind of within your data range. So if we take a look over here in our example, a telephone survey of 600 randomly selected people were conducted in an urban area. The survey determined that 76% of the people from 18 to 34 years of age have a social networking account. The results are accurate within plus or minus 4% points 19 out of 20 times. Okay? So the margin of error is what's in our example here. Plus or minus 4%. This right here is our margin of error. Okay. So if someone asks you for the margin of error, it's whatever that plus or minus is. Okay? So it's really just knowing about the terms of what someone is asking you to represent the data like. Okay? So if they're asking you for the margin of error from something, it's the plus or minus part. Okay? The next one is the confidence interval, right? So an interval, we saw intervals in our frequency polygon. It's like an initial number to an ending number, right? That was our interval in our polygons, right? Guess what a confidence interval is? Okay? An interval in which the value you're trying to determine is estimated to lie within a stated degree of probability, okay? So the confidence interval may be expressed using a plus or minus notation, such as 54% plus or minus 3.5%, or ranging from 50.5 to 57.5. How did they get this 50.5 to 57.5?
Possibility.
They took 54 and added 3.5 to get you the 57.5. And they took the 54 and subtracted 3.5 to get you the 50.5. So the confidence intervals in our example there would be 76 plus or minus 4%, right? So it would actually go from 72 to 80% would be the confidence interval. And you can represent them in two different ways. The plus or minus way, or actually adding and subtracting that plus or minus to that number. Okay? The last thing is confidence level. So you have confidence level, you have confidence interval, and you have margin of error. Okay? So the margin of error is just the plus or minus. The confidence interval is the lowest number to the highest number that the data falls into. Okay? And the level, confidence level, is how confident are you, right? Is basically what a confidence level is. How confident are you? Okay? It's the likelihood which the true population lies. Okay? When we were listening to the election, right? They had confidence levels. Sometimes they said it was 90% or they said 18 out of 20, stuff like that. You saw that. That's telling you how confident they were in their results that this is actually what's going to happen. Okay? A lot of times you'll see a level that says 95%, although lots of times confidence between 90 to 90%. And sometimes instead of saying they're 95% confident, because it sounds it sounds too easy to say, I'm 95% confident. So they say they're confident 19 out of 20 times or 18 out of 20 times. Makes them sound a little more smart, right? A little more educated to say 19 out of 20 times. Okay? What does 19 out of 20 times mean? Yet again, it's a fraction, right? 19 out of 20 times means 95%. They're just adding extra words to make it sound really, really awesome for you guys. Okay? So confidence level is how confident they are in their data. Sometimes they write it as a percentage. A lot of times they write it as 9 out of 10 times. 4 out of 5 dentists, right? That's their confidence level in their product or in their answer. Okay, so in here, our 19 out of 20 times, that's our confidence level, right? And it's 95%. So in our example here, it says, how can this result be interpreted if the total population of 18 to 34-year-olds in Canada is it in Canada? Yeah, 92,500. Okay? So calculate the range of people that had the social networking account. Well, we know the interval, right? The interval was 76% plus or minus 4%, right? Or it's 72% to 80%, right? That was our confidence interval, right? Okay, so those are our confidence intervals. But this is asking you for a range of people, so the actual number. How do we get the number instead of the percentage?
Times percentage, right?
Good. We know there's 92,500 people. Well, the lowest number it can be is 72%, right? So I times this by 92,500, and I times this one by 92,500. What do we have to make sure when we're multiplying? We change the percentage into decimal percent, right? So 0.72 times 92,500 gives us
66,600.
66,600. Like that. Ooh.
The other one is 74,000.
Okay. So the range of people that fall into having a social network is 66,600 people to 74,000 people from the age of 18 to 34 that have a social network in Canada. Mm-hmm. Okay. So, sorry, I'm making people busy now. Based on this survey, what is the range for the 18 to 34-year-olds that do not have a social network?
20. So you minus the
So,
numbers from 100?
from 100, right? Now, so here's the thing. We knew it was, what, 72 to 80%, right? So 100 minus 80 would give us 20%. That's our lowest number. What was the other number?
20 to 28%.
It was 72, and then 100 minus 72 would give you 28%. Now this is the confidence interval. How do we get the range of people? We times by 92,500. Okay? Or the other thing you could do is take 92,500 and subtract off that 66,600 and subtract off that 74,000. Okay? It depends on what you're really happy with. We're going to do both ways. Okay? So we got this 20% to 28% because it was 72 to 80, right? So 100 minus 72 gave us the 28. 100 minus 80 gave us our 20. So I'm just going to continue on with A underneath. So what's 20% of 92,500? And you said that was what? 18,500. And then 28% of 92,500 is?
25,900.
Okay. So this would be that range. Okay? Now I told you I was going to show you the other way you could come up with that range, right? And so our original range went from 66,600 to 74,000, right? If we take this 92,500 and we subtract each of these numbers from it, 92,500 minus 66,600, I'm going to have to carry one, using 2 zeros, 15, 9, thank you, 11 minus 6 is 5, and then 8 minus 6 is 2. Notice it gives you that back number, 25,900, right? And then if I do this subtraction, 0, 0, 5 minus 0 is 5, 12 minus 4 is 8, 8 minus 7 is 1. And that gives you that first number, the smaller number. So you can come up with the range two different ways. Yeah?
Will we adopted to put 25,900 to 18,500?
Usually you always write it the lowest to the highest, right? It still is a range, like you still put that dash in between and you're going down. So I won't documark, but the nicest way and usually the correct way to represent the data is always lowest from smallest to largest, okay? So part B here, the same telephone survey was conducted by a different company using a sample of 600 randomly selected people in both urban and rural. According to this survey, 76% of the people from 18 to 34 have a social networking account. The results are accurate, plus or minus 5.3%, 99 times out of 100. How are the results of this survey different from those to the first survey? How are they the same? So let's just verbally talk about this. How are they the same? They got the same middle number, right? 76%. Okay. However, their interval is, their margin of error is larger, plus or minus 5.3%. So it's actually going from, what? 70.7 to 81.3. Good thing I have a calculator in my classroom. That's awesome. Okay, so the confidence interval is larger, right? What about their confidence level? It's higher too. 99 out of 100 times. Well, why don't they just say 99%, right? It's the same thing. They're confident to 99%. It makes sense they have a higher confidence rate because their margin of error is wider, right? So they have a general wider area for their confidence level, so they should be more confident in their answer, right? We okay with this? All right. So moving down to example 2, apply the math. It says polling organizations in Canada frequently survey samples of the population to gauge voter preference prior to elections. People are asked, if the election was held today, which party would you vote for? If they say they don't know, then they're asked, which party are you leaning towards? Okay? The results of 3 different polls are taken during the first week of November 2010. That's our old election. Sorry, I didn't put our new election stuff in. Are shown on the next page or shown below. The results of each poll are considered accurate 19 out of 20 times. Okay? What's your question? Yeah, go for it. Okay? So if we take a look, can I show you something? The bigger the sample size, what do you notice with the margin of error?
Bigger or smaller?
Okay? The bigger the sample size, it's usually the smaller the margin of error, right? Because you've polled more people on average, so you're more confident in your answer. Okay? If I ask 3 of you guys, okay, I'm going to talk about a controversial issue right now, okay? If I ask 3 of you guys about your whole jacket buying thing that's going on, or I probably would get maybe not the proper answer depending on who I ask, right? I might get 3 different answers. I might get 3 of the same answers depending on who I ask, right? Just what's going on with your jackets even would be a random enough question. Now, my margin of error with just asking 3 of you would be quite large, right? But if I took you all aside and individually asked you, I'd be more confident with my answer, okay? So my margin of error would go smaller the more people I ask, is kind of what I'm telling you. Sorry to talk about that, okay? Now, so if you look at the sample size, the bigger the sample size, usually the smaller the margin of error, okay? So which numbers do you think you would be most wanting to follow? Probably the echoes, just because they have a higher sample size. Even if they didn't give me the sample size, their margin of error is quite smaller, so sometimes I feel when it's a smaller margin of error, they've asked more people, right? So the margin of error, how the sample size, the bigger the sample size, the smaller the margin of error, right? And then the confidence intervals in the reported things. So how would we figure out the confidence intervals? Well, this is conservative 20, let's just look at conservatives, okay? So conservative 29% plus or minus 2.3. So if I was going to do the confidence intervals for the conservative, 26.7, right? To 29 plus 2.3, 31.3. Okay, so that's the confidence interval in the conservative for the ECOS one. Nanos is 37 plus or minus 3.4%. So if I minus 3.4%, 33.6 to 40.4. And then in the Ipsos, plus 3.1 minus 3.1 gives me 31.9, and 35 plus 3.1, 38.1. Okay, so if we look at the confidence intervals, let's just look at them for the conservatives. But ECOS ones, the interval is lower than both the nanos and the Ipsos. They don't even correlate or overlap, right? They don't overlap with each other, like if I were to draw them. But the nanos and the Ipsos overlap with each other, right? Ipsos is a little lower, but that 3.36, they meet till 38.1. They overlap each other, right? So sometimes people go, well, these guys are in the same range as each other, and this guy is way off the mark, right? Just by looking at different polling stations. So they might start thinking, well, maybe the nanos and the Ipsos, even though their margin of error is slightly greater, they've got a commonality at least in their confidence intervals, right? And so because they have a commonality, maybe these ones are closer to the actual results. Okay, maybe. Okay, it's just a way of looking at the data. You never know until that day. And some people, when they get that phone call and they've got it for the third time, and maybe ECOS was the third time calling, they just randomly tell them something else because they're tired of getting those phone calls, right? But depending on how political you are, you want your party to come ahead, and then you'll always say your party's name, right? It just depends on who you are. I have one more question, right? Are we on example 4 way at the bottom? I left lots of room for talking, but we didn't actually write anything down. Okay, a poll was conducted to ask voters the following. If an election were held today, would you vote? The results indicated 53% would vote for Smith and 47% for Jones. The votes being accurate within 3.8%, 19 out of 20 times, who will win? Just some random people. Well, let's look at the intervals. If I subtract 3.8, that's 49.2, and I add 3.8, that's 56.8. Okay? This is Smith. And if I look at Jones, 47 minus 3.8 will give me 43.2. And if I add 3.8, will give me 50.8. So there's some overlapping, right?
Yep.
Between Smith and Jones' number. So I would say probably Smith would win. However, I can't be for sure because of the confidence intervals overlapping. Okay? So I would say I'm not quite sure because of the fact that the confidence intervals overlap. However, because Smith has a slightly higher percentage, I'm probably going to choose Smith. Okay? So if you need to, there's some key summaries here, just explaining some things again, going through some of the terms. You're welcome to read through that. I'm just going to stop right now and I'm going to find a textbook to get your assignment. So your assignment is from page 274. It's questions 3 to 6. Your choice of odds or evens.